Welcome back to Module 1, Voting Methods. This is Part 2, so if you have not already watched Part 1, please go back and do so. Remember to use your textbook, take notes, pause this video, go back, do the problems yourself, and replay the sections as many times as you need. We're going to get started with Plurality with Elimination, Section 1.4. So, plurality with elimination, the objective here is we want a majority. So most elections require a majority to win, but plurality doesn't necessarily mean a majority. So using elimination in an election can create a majority by eliminating the candidate with the fewest first place votes and then holding a runoff election. The thing is, runoff elections is another election, which means it's expensive and it can be inefficient and cumbersome and it can be very time consuming. The more efficient solution that does not require an additional runoff election is using preference ballots. So that preference ballot that we talked about in Part 1 shows not just the first choice, who we want to win, but the voter's choice between any pair of candidates. So we can eliminate the candidates with the fewest first place votes one at a time until one candidate has the majority. Now, plurality with elimination is often called instant runoff voting, and that's mainly what you'll probably hear in the media if a particular county or city uses this method. I'm going to go through how to do it, and then we'll do an example. So the first thing we do is we count all the first place votes for each candidate. If a candidate has a majority of first place votes, then that's the winner and we're done. But if we don't have a majority, we eliminate the candidate or candidates if there's a tie with the fewest first place votes. Now, we cross the name out of the candidates, eliminated from the preference schedule. Any candidates below that candidate get moved up, and then we recount the first place votes. If a candidate has a majority of first place votes, then that candidate is the winner. Otherwise, we repeat the process until a majority has been chosen. Okay, so let's look at an example with that math club election. So here's the preference schedule that we're pretty familiar with at this point. Okay, round 1. We count the first place votes. So in this case, we have, if we look back here at our original, we have A has 14, C, if we add the 10 and the 1, we get 11, and then you see from there. So who has the lowest number of first place votes? Well, that would be B. So B is going to get eliminated. Now, B gets eliminated, so let's get rid of B. Okay, so B is gone, B is gone, B is gone. And the cool thing is now D gets to move up, and those 4 votes now go to D. So remember, B is gone, D got those 4 votes, so now D has 12. So if you look here, we can see that, all right, C is going to get eliminated next because we still don't have a majority. So now again, remember here, C got eliminated, D moved up, and now C is gone. So you can see all the C's are gone. In the first place, the C is gone, that B is gone, so this D gets to move up. And so now we can look here. All right, now D has 23 votes, A has 14, that's the majority. And so now we have a winner. It's not Alicia or Boris like before. With 23 votes, the winner is now Dave. So what's wrong with this method? The main problem is, well, you'll see in the next example. Okay, so let's look at an Olympics example here. We've got Athens, Barcelona, and Calgary. They're all competing. There's going to be a secret vote of 29 members. Now, they decide they want to do just an unofficial straw vote just to see where everyone stands. So here are the results of the straw poll. So if we're using the same method, plurality with elimination, so we see here, okay, Athens has 11, Barcelona has 8, and Calgary has 10. No one has a majority, so we get rid of the first place one here. So Barcelona's getting eliminated, Calgary's moving up, and now those 8 votes go to Calgary, and so we've got 11 for Athens, and we've got 18 for Calgary, which means that Calgary is actually our winner. So based on the results of that, we can say, okay, Calgary is going to win the election in a couple days. So although the results of the straw poll were supposed to be secret, the word gets out as these things happen that Calgary is probably going to win. And so everybody loves a winner. The 4 delegates in this last column here that voted for Athens first decided, hey, you know what? Let's vote for Calgary. If Calgary's going to win, what's the harm in doing that? So that's exactly what happens. Those last 4 changed their vote. So let's take a peek here. Remember, these 4 people said, all right, we are going to not vote for Athens. We're going to put Calgary first. And then if you notice, their ballot's now the same, CAB. So now 14 people vote for Calgary first. And okay, but the problem now is that Calgary doesn't have a majority anymore. So we still have to eliminate the person with the least amount of first votes. So that would be, in this case, Athens. And so now Barcelona gets moved up, and those 7 and 8 votes become 15 votes, and now Barcelona actually wins. So what happened here? Calgary ended up getting more votes for the first round, but then lost. And so this is a weird quirk about plurality with elimination. There's a possibility that you can actually do worse by doing better. So where is this actually used in real life? It is used in Olympic committees to choose cities, and it's used in several cities and another country in Australia. So section 1.5, we're going to talk about the method of pairwise comparisons. So in pairwise comparisons, the goal here is that every candidate is actually matched head-to-head against every other candidate. So if we're looking between X and Y, then every vote is either assigned to X or Y, and the vote goes to whichever is listed higher on the ballot. The winner of the pairwise comparison gets a point, and the loser gets none. If it's a tie, you get a half point. The winner is determined by the candidate with the most points after the pairwise comparisons are added up. So overall, point ties are common under this method, and as with other methods, the tie is broken using whatever determinant they've already decided. Okay, let's go back to our math club election. We're going to compare A and B. So we're going to look at A as red and B as blue, and we're not even looking at C and D. So in this next slide here, we're comparing A and B. So basically, when does A perform higher or more preferred than B? So if you look here, A is above B, 14 voters put A above B. But if you look here, B is ranked above A, above A, above A, above A, 10, 8, 4, 1, 23 times. So who has a higher ranking? The ranking would go to B. Between A and B, B gets the point. And that's exactly how this works. We'll do it just one more time here. So if we're comparing C and D, so again, we're looking, okay, C is above D. C is above D, and C is above D there. However, D is above C, and D is above C. So when we add up those comparisons, we can see that, hey, C actually gets the point. So what I'd recommend you doing is pausing, doing the comparisons for all of these head-to-head candidates, and then you can do that yourself. I'll just tally that up here. So in this case, when we tally up all the points, we actually get C, or Carmen, as the winner. Now, we have done 4 methods of fair voting counting, and we've gotten 4 different winners. So the method of pairwise comparisons satisfies 3 of the fairness criteria we're going to discuss in the next section. But why don't we do it then? If it's the, quote, most fair, well, because it can get really time consuming. 5 candidates, we would have to do 10 comparisons. 10 candidates, 45, and you can see that that's just extremely time consuming. The last thing we're going to talk about is fairness, and what I suggest you do is follow along with this and then go back through all the sections and look at how the fairness criteria is broken and upheld with each method. So we've studied 4 different methods, and now there are 4 different fairness criteria. We've got the majority, the Condorcet, the monotonicity, and the independence of irrelevant alternatives criteria. And this all has to do with Arrow, who we'll be discussing in our discussion board, but Arrow has done a lot of work on fairness of elections. So the majority criterion states the following: a majority should always win the election. And remember, a plurality is not a majority. The Condorcet candidate should always win the election. And basically what that is the candidate that compared to two at a time beats all the other candidates. The best example we covered is the Hula Bowl versus the Rose Bowl. So we're not just saying the majority wins, but we're saying that head to head, everybody prefers this candidate over the others, or the majority. Suppose a candidate wins an election, but for some reason there's a new election. If the only changes are more votes for the original winner, then they should win the new election. And that seems like an obvious thing, but if you remember the Olympic example, when they thought, oh, this person's going to win, I'm going to put more votes in for the winner, it actually changed the election. And the IIA is, suppose a candidate wins an election, but for some reason there's a new election. If the only changes are a candidate withdraws or is disqualified, the original winner should still win the election. So I recommend you go check out the NFL example in section 1.5. So those are the 4 fair criteria. And honestly, they seem kind of obvious, like the majority should win, head to head, that person should win the majority of the time. These are the basis that Arrow says establish a minimum standard of fairness. We studied 4 methods, and not a single one meets all 4. So take a moment here to look at which method violates which fairness criteria. So what voting method satisfies the minimum standards of fairness of the 4 criteria? For a democratic election involving 3 or more candidates, it's just not possible. We don't have a voting method in place for that. So does that mean voting is unfair? Does that mean we shouldn't vote? Does that mean we're wasting our votes? I'll leave that for you guys to discuss in the discussion board, and that concludes the lecture notes for Module 1.